Hello everyone, welcome back to my channel. Here I have a small round magnet like this. Today I'm going to combine it with some old components and try turning it into a mini DIY antenna capable of receiving real signals. Next, I have an old watch here that no longer works. I removed the battery from inside the watch to inspect it. First, I use a multimeter to check whether the battery still has any power left. I place the two probes onto the positive and negative terminals of the battery. However, the reading shows 0 volts. This means the battery is completely drained and can no longer function normally. I'm going to reuse this old battery as a component for the DIY antenna. Even though the battery can no longer store power, the internal metal parts can still be used for electrical conduction and antenna connections. First, I use pliers to remove the outer metal casing of the battery. Then, I use a utility knife to cut away the plastic wrapping around the center section. After removing the outer layers, the internal metal core becomes exposed and easier to connect with wires. Next, I prepare 2 long copper wires to create the connection between the battery and the antenna system. I tightly twist the copper wire around the end of the battery to create a stronger electrical contact. Then, I use pliers to tighten the copper wire connection onto the battery. This helps make the connection more secure, prevents the wire from loosening, and improves electrical contact during the antenna's operation. In the next step, I'm going to make an artificial battery to replace the dead battery from the watch. Here I have a plastic tube about 7 centimeters long, and I think it's a suitable size for building the body of the new battery. I close both ends with plastic caps to make it resemble a real battery. Then, I place it behind the watch to check whether the size fits properly. After confirming the dimensions are correct, I'll begin building the new replacement battery for the watch. First, I use a drill to make 2 small holes at the center of the plastic caps. These holes will be used to install the electrical connection points for the artificial battery. Here I have 2 small bolts, and I attach them into the holes that were just drilled into the plastic caps. Next, I begin connecting the electrical wires to the battery caps. First, I use pliers to strip the insulation from the wires and expose the copper cores inside. Then, I twist the exposed copper wire around the bolts to create a stronger electrical connection. After that, I insert the bolts into the holes on the plastic caps and use pliers to push them through to the other side of the caps. Once the bolts are fixed in place, I twist the matching colored wires onto the opposite ends of the bolts to complete the electrical connections for both ends of the artificial battery. For the remaining plastic cap, I repeat the same process but use the two red wires for the connection. I twist the exposed copper wire around the bolt to create a stronger electrical contact before attaching it to the plastic cap. Next, I bring in an aluminum strip and a small copper tube. These two parts will be installed inside the 7 cm plastic tube to form the electrodes of the artificial battery. First, I use a ruler and marker to measure and mark a suitable length of about 6.5 centimeters so the pieces can fit properly inside the tube. I use pliers to cut off the excess parts of the two metal pieces. This helps keep the electrodes compact, prevents them from touching each other inside the tube, and makes the assembly process easier. Then, I place the copper tube onto the vise surface and use a hammer to flatten it slightly. This makes it easier to insert into the plastic tube and increases the contact area inside the battery. For the aluminum strip, I also hammer it flatter and thinner before placing it inside the tube. Next, I drill a small hole at the end of the copper tube to make wire connection easier. Then, I connect the red wire from the plastic cap to the copper piece to form the first electrical terminal. For the blue wire from the remaining plastic cap, I connect it to the aluminum piece to create the second terminal of the battery. This trick works by combining two different metals, copper and aluminum, together with salt water inside the plastic tube to create an electrochemical reaction. The voltage difference between the two metals generates a small electrical current, turning the tube into a simple homemade battery. Next, I insert the aluminum strip into the plastic tube first. Then, I apply hot glue around it to hold the aluminum securely in place. I repeat the same process with the copper piece, so both electrical terminals are positioned inside the tube. In the next step, I place some cotton inside the tube. The cotton helps absorb and retain the saltwater solution inside, allowing the electrodes to stay in contact with the electrolyte during operation. Next, I prepare the saltwater solution. I add about 2 spoonfuls of salt into a cup of water and stir it until the salt completely dissolves. Once the solution is ready, I use a syringe to draw up the salt water and slowly inject it into the plastic tube. The cotton inside begins absorbing the solution and keeps the salt water around the metal electrodes. After finishing the electrolyte section, I attach the plastic caps on both ends of the tube to complete the artificial battery. Finally, I apply hot glue around the edges of the caps to seal all the gaps tightly. This helps prevent saltwater leakage and makes the homemade battery structure more secure during use. Next, I use pliers to strip the wire ends on both sides of the artificial battery in preparation for connecting the power source. Then, I gently shake the battery so the saltwater solution spreads evenly through the cotton and around the metal electrodes. Next, I bring in a power adapter that is already connected to a plug to serve as the external power source for the system. First, I use a multimeter to measure the voltage output of the charger. I touch the probes to the 2 wires from the charger to check its output voltage. The reading shows around 20 volts, which means the charger is still functioning properly and can provide power for the experiment. Next, I twist the 2 wires from the artificial battery together with the 2 wires from the charger. The purpose of this step is to supply electrical current into the electrochemical system inside the homemade battery, helping generate a more stable electrical output for the device. Next, I move on to completing the DIY antenna assembly. First, I glue the artificial battery onto the surface of the round magnet. Here I have an old and used SIM card, and I want to reuse the metal chip on it as a connection point for the antenna system. I use hot glue to secure the SIM card onto the magnet so the parts stay fixed during assembly. Next, I bring in a roll of solder wire and begin soldering 4 small solder points onto the surface of the SIM chip. These solder joints will serve as electrical contact points for connecting the remaining parts of the DIY antenna. Next, I use pliers to tightly twist the 2 copper wires onto the terminals of the artificial battery. Then, I use a soldering iron to secure the connections so the electrical contact becomes stronger and more stable. For the remaining 2 copper wires, I bend them toward the solder points on the SIM card chip. After that, I use the soldering iron again to solder the copper wires onto the SIM chip connections to complete the antenna signal circuit. I'm going to reuse an old charger with a built-in cable as the connection wire for the antenna. For the remaining 2 solder points on the SIM card, I solder them to the 2 wires coming from the charger to provide power for the entire system. Once everything is connected, the wires and solder joints now form a complete DIY antenna assembly. Here, I already prepared a signal cable with a female connector on one end and a TV jack connector on the other. I connect the antenna plug to the signal cable to complete the final antenna setup. Now, I'm going to test this homemade antenna in real-world conditions to see whether it can receive TV signals successfully. Now, I'll try switching channels on the TV to see if it can receive any signal without an antenna. As you can see, without an antenna connected, the TV cannot receive any signal at all. The screen shows a no signal message, meaning no broadcast channels are detected. Next, I connect the DIY antenna to the back of the TV for testing. As soon as I turn the TV on, the channels appear almost instantly. The picture is clear and stable, showing that the antenna works effectively. To verify this further, I remove the antenna and reconnect it again. When I unplug the antenna, the signal disappears immediately. And when I plug it back in, the channels return as normal. This clearly proves that the DIY antenna works well in real-world use. As I change channels, the TV continues receiving signals quite steadily, and the picture remains relatively clear. Several channels appear quickly without constantly losing signal. This shows that the homemade antenna built from recycled components can actually work quite effectively in real conditions. After about 30 minutes, the artificial battery had received enough stored energy, so I disconnected the wire connections from the charger. Next, I use a multimeter to measure the voltage of the homemade battery. When I touched the probes to the battery wires, the meter displayed around 1.34 V. This shows that the homemade battery is capable of generating usable voltage for low-power devices, such as this watch. After that, I attached the artificial battery to the back of the watch. I applied a layer of hot glue behind the watch and fixed the battery onto it. The two battery wires were placed directly against the contact terminals inside the battery compartment. Next, I used additional hot glue to fill the empty space inside the compartment, while pressing the wires firmly against the contact points. And as you can see, the watch immediately started working again. To prove this is real, I removed the hot glue from the contact area, and the watch instantly stopped working. Then, once I reconnected the wire contacts, the watch began operating normally again. So, using only a magnet, an old battery, and a few discarded items, I was able to create a functional DIY antenna and even build a simple homemade battery. If you enjoyed this video and found it helpful, don't forget to leave a like and subscribe to support the channel. Thank you for watching, and I'll see you in the next DIY videos.